Imagine a line in a coffee shop. The first person in line gets served first, right? That's exactly how queues work in data structures. A queue follows the first in first out principle. Just like in a coffee shop, the first person to get in line is the first one to get served. In programming, we use queues to manage data in a specific order. And remember that in queues, the action happens at both ends. Queues are vital in programming for tasks like managing requests on a server or handling data in a real-time systems and scenarios where order matters. They ensure that everything gets processed in the right order, maintaining fairness and efficiency. We use queues when we need to maintain the order and quick access at both ends. They are good for task scheduling, order processing, and breadth-first search in trees or graphs. Now let's see the big O complexities and performance of queues. Queues support primary operations like enqueue, which is adding to the back, dequeue, which is removing from the front, and peek, which is looking at the front item. These operations are super fast, each with a time complexity of O of 1. However, like in any other data structure, queues have their nuances. Searching and removing specific elements in a queue are O of n operations, as you might need to traverse the entire queue. It's not what queues are best at, but it's possible. Remember that queues are mainly used in scenarios where order is important and operations are happening at both ends. Let's take a step back and understand how queues are actually implemented under the hood. In many programming languages, including JavaScript, you can implement a queue using arrays. Arrays provide a simple and intuitive way to represent a queue. However, there are some nuances to be aware of in terms of performance. While push operations are O of 1, shift operations are O of n because all remaining elements need to be shifted down. If performance is critical concern, especially for large datasets, this might not be a best choice. A more efficient way, especially for dequeue operations, is to use a linked list. In a singly linked list, enqueue operations are O of 1, and if we maintain a reference to the last node, dequeue operations can also be O of 1. With this approach, both enqueue and dequeue operations are consistently fast, and the peek operation is O of 1 in both cases. Now that you've got a good grasp on queues, head over to LeetCode and try solving number of recent calls challenge. You need to implement the ping method, which will keep track of times of the recent requests, and think about the time complexity of the ping function and how using a queue can help maintain an efficient solution. In summary, queues are first in first out data structures with constant time operations for adding, removing, and picking elements. They are your go-to when order and efficiency matter. We also have last in first out data structure, which is the opposite of queues. They are called stacks, and if you'd like to learn more about them, check out this video about stacks data structure.